All right, hey guys, so we are going to finish up lesson 7.2 by working on some proofs together. So this is day 2 of lesson 7.2. Let me present my screen and we'll get started. All right, so day 2, we're going to, as I said, work on some proofs, but we need to review what we know about parallelograms. So basically the definition and then all the theorems, they gave us all the different properties of a parallelogram are what we need to write down because those are going to be our justifications in the proofs. Okay, so list what you know about a parallelogram. All right, so let's start, ignore that. Let's start with the definition. What does the definition tell us? The definition tells us that opposite sides are parallel, right? It's a parallelogram, opposite sides parallel. So opposite sides parallel. Okay, and I'm just going to mark the diagram. I'm not going to list all the statements. So opposite sides are parallel. Okay, what else do we know about the opposite sides? Well, the first theorem we learned was that opposite sides, that's an S, are congruent. So I can mark them congruent to each other as well. Okay, let's move on to the angles. What do we know about the angles? We know that opposite angles are congruent. So K is congruent to M and angle J is congruent to L. Okay, what else do we know about the angles? There's one other thing we learned about the angles. We learned that consecutive angles like J and K or J and M are supplementary. So we learned that consecutive angles are supplementary. They add up to 180. Okay. And what's the last thing? There's really no way to mark that. I guess I could, as an example, say the measurement of angle J plus the measurement of angle M equals 180. I'm not going to list all of the different equations. That's just one example. Okay. And the last thing we learned was about the diagonals. What did we learn the diagonals do to one another? They bisect each other. So 3 tick marks, and then it's going to get messy, 4 tick marks, 4 tick marks. Okay, so we learned that the diagonals bisect each other. All right, again, this is all important information because these are the justifications we're going to be using in our proofs. Okay, and you'll see how we write them as we get into the proofs. All right, so for our lesson today, we're actually only going to do the 2 proofs on this page and then the other pages of this document. So this page here, there's 4 proofs. We're going to do those probably together in class one day. And then I'll probably leave this for you to practice on your own or something around like that, okay? So we're just going to get through these 2 proofs, okay? So let's start with setting up our T-chart statements and reasons. Statements, reasons. All right, so the first statement is we're told that A, B, C, D, this figure here is a parallelogram. So instead of writing out the whole word parallelogram, we just actually draw a little parallelogram symbol. So parallelogram A, B, C, D. So right off the bat, you know all those 5 facts. I think there's 5 of them. 1, 2, 3, 4, 5. Yeah, all the 5 facts that we just wrote above is true for this figure. I could say that A and C are congruent, angle B and D are congruent, side AB, right? There's so many facts that I could list. Now, I'm not going to list them all because I only want to list what I need. All right. Let's also write down the other piece of given and we'll mark it. All right. We're told that AK is equal to MK. So I'm going to mark AK. Okay. So for this, the way I mark it is I do like a little bracket thing. AK is congruent to MK. So this whole side is congruent to that whole side. Okay. Now we're trying to prove, let's look at what we're trying to prove. We're trying to prove that angle BCD, so this angle right here, is congruent to angle CFE. CMD, this angle here. So again, I want to prove that this angle here, I'll mark it for just a minute and then I'll erase it. I want to prove that that angle is congruent to this angle. All right. Now, if you're not sure where to begin, because maybe there's a lot of facts going through your head, what I often suggest to do is think about what one of the pieces of information you need to prove and think how you can introduce that into the proof. Okay. So for example, what do you know about angle M? What do you know about angle M? Well, let's take a step back and think about the fact that you're told that this side here is congruent to this side here. What kind of triangle do I have? What kind of triangle am I looking at? You're looking at an isosceles triangle. So let's list that down. We know that triangle AKM is isosceles. And how do I know it's isosceles? Well, it's because the two sides here are congruent. That's the definition of an isosceles triangle. Def of isosceles triangle. Now that's going to help me introduce angle M into the proof. Okay, if that's an isosceles triangle, what do you know about the base angles? Angle M and angle A. What do you know about them? You know that they're congruent because base angles of an isosceles triangle are congruent. So I can say that angle A is congruent to angle, you could call it M, but I think just so that I match how the proof is written, I'm going to write CMD. I probably, if I retype this, I would probably just call that angle M, make it easier. It's the same thing, right? You can use one letter for that angle. All right, so I know angle A is congruent to angle M. All right, so, and how do I know that? It's the base angle. They're the base angles of an isosceles triangle. That's the isosceles triangle theorem. Or you could just say base angles of isosceles triangle are congruent because that's what the theorem says. All right, so I need to somehow bring this angle into the proof. I already have this angle in the proof, but now I need to somehow introduce this angle, angle BCD, into the proof. Well, because you have your parallelogram, don't you know that opposite angles are congruent? So can't you say that angle A is congruent to angle BCD? So let's say that next. Angle A is congruent to angle BCD. And that's because since you're given that it's a parallelogram, that implies opposite angles congruent. And that's how we write our justification. Parallelogram implies opposite angles congruent. Again, it's basically saying because I was told I have a parallelogram, I'm allowed to conclude I know that the opposite angles are congruent. That's one of the theorems we learned. All right, hopefully you're seeing how this is coming together because this is not obviously our first proof we've ever done. Take statements 3 and 4 to come up with statement 5. If A is congruent to angle CMD and A is congruent to angle BCD, you can say that angle BCD is congruent to angle CMD, and that you could say substitution or transitive, either one is acceptable for me. Okay, substitution, or I would take transitive. Okay. And that's it. You're done your first proof. Okay, let's go through one more together. All right, statements and reasons. I think this one might actually be easier than the first. I'm trying to quickly look at it as I'm setting it up. All right, you're told that EFGH is a parallelogram. So EFGH, the big, I'll trace it in red if I can. Here we go. This big figure is a parallelogram. So again, lots of facts going through my head. Opposite sides congruent, opposite sides parallel, opposite angles congruent, consecutive angles, supplementary, diagonals bisect each other. We just have to figure out what pieces of that we need. You're also told that PQRH is a parallelogram. That's all given. And I will trace over that one in black. All right, so this one here is also a parallelogram. Now we want to prove that angle Q, this angle right here, is congruent to angle F, this angle here. Okay, that's what we're trying to prove. Well, let's first somehow introduce F or Q into the proof. Let's talk about what we know about one of those two angles. So you pick. Okay, let's say something about angle F. Okay, I know that angle F is congruent to angle H. Angle F is congruent to angle H. And how do I know that? They are opposite angles of a parallelogram. So I can say parallelogram implies opposite angles congruent. Now, with that same justification, can I say that angle H is congruent to angle Q because they are also opposite angle? I can. So I can also say that angle H is congruent to angle Q. I'll just leave it under the same statement because it's the same reason. And now finally, if F is congruent to H and H is congruent to Q, can't you say that angle F is congruent to angle Q? And again, I would take either substitution or transitive for this one. Okay, substitution or transitive. And that's it. All right, guys. So it's a quicker lesson today. As I said, we are going to work together on a few proofs in class, and then you will work on some independently as well. But that is it as far as lessons, just kind of getting you back into the mindset of how to work through proofs, and just knowing that the vocabulary, your theorems, your definitions are going to continue to be important throughout the chapter and through all of our geometry lessons so that you can work through your proofs successfully. Okay, so that's it. I'll see you back for the next lesson. Bye.